Hello, let's begin our class. Uh, this Monday, I updated the course website, and you can see the results of assignment 4. And assignment 4 will not be updated because the deadline has passed. I also updated the quiz results. You can check the scores. And yesterday I updated the accuracy results of assignment 5. And accuracy -1 means -1 means compilation error. So you need to check the send folder after you send your file. And if your accuracy is not 100%, then you need to test all the input-output samples. And for this assignment, I provided some samples to test the add item function. I provide 7 samples, and I also provide another 7 samples to test add and delete item functions. And you need to pay attention to the case that suppose you enter a command and its score is the same as some score in the leaderboard. Then you need to pay attention to the requirement of this assignment. And when you want to access elements of a vector, I always suggest to use the add member function instead of the brackets, because this can help you to detect index out of range errors. If you use brackets, this will not help you to find index out of range errors. So when you want to access some element in a vector, we should use the add function. And next week will be the final exam, and the rule is same as our midterm exam. Let's go to the constructors. We haven't finished this part. And we already introduced constructors, and also introduced the const keyword. And next, I will introduce the inline functions and the static member data. And when we define member functions, we usually separate declaration and the implementation. So let's see one example. For example, for this class, we have for this example, we have a member function get months, and this is the declaration function declaration, and its implementation is outside the class. So its implementation is this line. And sometimes we want to move if this implementation is very short, then we might want to move this implementation into the definition of a class. So you can, since this line is very short, you can move the implementation into the definition of class. So like this. Or you can use the inline keyword. Inline keyword means you don't need to manually move the implementation. So here you can use the inline keyword, and if you add this keyword, inline keyword, then this is similar to you move the implementation into the class definition. And this is usually for very short functions. If the functions if is very long, then we don't suggest you to use inline. Because if the function definition is too long, then inline will be less efficient. Next, I will introduce another keyword, static. The scenario to use the static data is when you want to share data across all objects of a class. If you need this property, then you can use static member data. So let's use this example as one example. And here I declare two objects, date 1 and date 2. And each object has its own member data, so I print the member data of date 1 and date 2. We need to define a constructor, so you can after we declare two objects, date 1 and date 2, and each object has its own member data. So and the member data are independent. Now suppose we want all objects of the same class to share some variable. Then we can use the static member data. And to do this, you need to add the static keyword before the data type. So number objects will become a common variable, common member variable uh, for all objects of day of year class. So both date 1 and date 2 can access static member data. And we need to initialize this static data, and unlike other member data, we directly initialize this this static data, this static member. So we initialize this static member outside the class definition. So we assign 0 as its initial value. And then we can modify the definition of this constructor. And here, inside this constructor, we increase the value of number objects by 1. And this means if this constructor is called, then the value of this static member will be increased by 1. First, I will move this member to data to public, so that we can directly print its value. Well, we can directly access the static member without using objects. So actually, we can directly print the value of a static member. So we see that we can directly access the static member without using objects. So to do this, you need to add the scope resolution operator and add the name of this class. So initially, its initial value is 0 because of this line. And after the first constructor, the value of this static member will be increased by 1. And after the second constructor, the value of this member is increased by 1 again. So after you declare 2 objects, the value of number objects is increased by 2. You can also use object to access static member data. For example, so you can also use objects to access this static member, or you can directly access this member without using objects. Next, I will introduce static member functions. Static member functions means you can invoke this function without using object. So you can, for a static member function, you can call this function without an object. Now, for example, we want to use getMonths. GetMonths is not a static member function, so you cannot directly call this function. So we cannot directly call a static member function without using objects. So here is the error message. So so the message is we cannot call this member function without object. So you need object in order to use this member function. So we need like this date1. We need to use date1.getMonths to use this member function. And next, I will show how to define a static member function. To define a static member function, we add the static keyword before a function. So here we add the static keyword. So this function is a static member function, and this means we can directly access this function with our objects. And here is the implementation of this static member function. So you see that we can directly call this static member function without using objects, and this function will return 0. 0 is the value of this static of number of objects. Next, we will have a quiz. So please raise your hand if you need answer sheets. This is the first question. Uh, 30 seconds left. Next, I will open the second question. 30 seconds left. Next, I will open the final question. The final question is to use an unstable sorting algorithm to sort this sequence according to the length of a string in ascending order. Uh, 30 seconds left. I will turn off all the questions. If you use answer sheets, remember to write down your name and student ID. Let's see the answers. For the first question, answer is option 1. So this sequence is not in alphabetical order. So this sequence all begins from S. So we need to check the second character. So the second character H should be before M. So the two words is not in alphabetical order. Let's see the next one. For this one, the answer should be option 2. The user inputs 5 characters, A, B, C, D, E, and this statement peak. So after peak, the CH at index 0 will be A, and the peak does not move the pointer, so the pointer still points to A. So after this line, after peak, the pointer still points at A, and the next statement, cin dot get. This function will read 1 character and move the pointer to the next position. So this function call will get A. So ch at index 1 will be A, and then the pointer will be moved to the next position. So the pointer will be moved points to character B, and the next line cin.get will read the character pointed by the pointer. So cin.get will read character B and move the pointer to the next position. So after this cin.get, the pointer points to character C, and the final the cin.pick will read character C. So the answer of this question is A, B, C. For this question, the answer is the option 4. All of the above sequences are possible. So we want to sort this sequence according to string length in ascending order. This means length 4 should be before length 5. And some strings are of the same length. For example, Bill and Alex are of the same length. And in this situation, unstable sorting algorithm cannot guarantee the relative order. So the relative order of Bill and Alex cannot be guaranteed by unstable sorting algorithm. So the position of Bill and Alex might be exchanged. So Alex Bill. So the third sequence is also possible for unstable sorting algorithm. And similarly, Zitela and Yolanda are of the same string length. So their position can be exchanged because they are of the same string length. But if we choose to use stable sorting algorithm, then the answer will be unique. So if we choose to use stable sorting algorithm, then the result should be option 2. If we use stable sorting algorithm, because for stable sorting algorithm, the relative order is maintained after sorting. if no further questions about the quiz, then I will return to the slides. We talk about static member functions. The purpose of static member functions is usually to access static member data. For this example, if I put the static I put the static member data in private, then I cannot directly access this static member because it is private. So now the static member data is private. So I cannot access it in the main function. So we need to use some member function in order to access this private member. I think the time is up, so let's take a break for 10 minutes. Hello. Let's begin our class. Uh, I have more questions for you to practice. Uh, Here is this is not the quiz. The quiz is already over. This is only for you to practice. Uh, you can determine the answer of this question, and after 30 seconds, I will announce the answer. Then I will announce the answer. Let's see each statement. The first statement is false because constructors does not return any value, and not even void. So we will not place a void in front of the constructor. So statement 1 is false. And statement 2 is true. We can explicitly call a constructor, and you can refer to the slides. Here we make a constructor code explicitly. You can directly use the name of this class. And this is the constructor. You can use this constructor. You can make an explicit constructor code. So statement 2 is true. And statement 3 is false. This is not a must. This is optional. So you can choose member variables to be public. And statement 4 is also false because we cannot access private members outside the class. So the next question is about a constructor. So after 30 seconds, I will announce the answer. And then let's see this question. When will a constructor be executed? And option 1 is wrong. Option 1 is false. When we define a class, this will not call a constructor. For example, here. For example, here we define a class day of year. When you define this class you do not call a constructor. Only when we declare object like this, only when you declare object, then you call a constructor. So option 2 is true. When we create an object, and this time we'll call a constructor. So the answer of this question is option 2. And option 3 is also false. When we use an object, we might not use a constructor. For example, when you access some member, when you use this object to access some member or some member function, this will not call a constructor. So for this question, the answer is option 2. The next question is also about constructor. The left-hand side is the source code, and the right-hand side is the question. And you can determine the value of my.x and my.y after you declare this variable. Let's see the answer of this question. Here I use my class to declare an object, and we know that this will call a constructor. This will call the default constructor because we do not use parentheses. So this will call the default constructor. And here is the declaration of the default constructor, and its implementation is here. So here is the implementation of the default constructor. And x is set to -1, and y is set to -2, And also, we know inside the braces, there is a function crop. So inside the braces, the member function crop will be executed. So we need to see the definition of this member function. So crop means if x is less than 0, then x will be set to 0. And similar operation is applied to y. So after this crop function, both x and y will be set to 0 because they are both negative. And therefore, the values of my.x and my.y are all zeros. So the answer is option 1. Next, let's return to our slides. Let's see this example. Suppose we want to access the static member data, number objects, and this member is private, so we cannot directly access. We cannot directly access this member. We need to use member function. And now suppose we want to access a member function without using objects, then we need to use the static member function. So now suppose I want to call the member function without using objects. Then I need to use the static member function. So here we declare get number objects to be a static member function. Here we put static before the return data type. So int is the return data type. And here the 2 lines are the implementation of this static member function. This is like the usual member functions. So here I make a function call to this static member function. I don't use any objects. So you see this function returns 0. And after we declare 2 objects, the value of number objects is increased by 2 because we make 2 function calls. We make 2 function calls of constructors. And after that, if we print this state, if we print the value of this static member, so this function will return 2. Here, this slide provides some remarks about static member functions. A static member function can only use static data and static functions. And this means you cannot use user member data in static member function. For example, now suppose I modify the definition of this static member function. Suppose I modify the value of the member data months, and this will cause syntax error. Sorry. So this will cause syntax error. Month is a member of day of year, but we cannot use this member inside a static member function. The reason is clear because because we can call a static member function without objects, and this member should belong to some object. And if we can call this function without object, then we do not have the value of months. So this is the reason why we cannot use other non-static member in a static member function. And we have finished this chapter. And next, we will go to pointers and dynamic arrays. We haven't finished this chapter, so let's see the slides of this chapter. For this chapter, we already learned pointers and dynamic arrays, but we haven't finished the third topic. So next, I will introduce pointers and the pointers and classes. First, let's see page 17. Let's see the arrow operator. The arrow operator. This operator is used with a pointer to some object. For example, we can declare a pointer to some object. So here, day of year is a class, and the day of year star is a data type. We can use this data type to declare a pointer. And the next line. Here the next line use the new operator to allocate the memory space of one day of year object, and this will call a constructor because here we use the parentheses. So this new operator will allocate the memory space of one day of year object, and also call the constructors. A constructor with 10 and 25 as the inputs. And this new operator will return a pointer. So this pointer is assigned to dptr. Then we can use dptr to access the members of this object. We have two options. You can use the reference, or you can use this arrow operator. So if we want to use the reference operator, then we need to add the parentheses. After we use the reference operator, we obtain an object, and then we can use the dot operator to access member data or member function. Here the parentheses is required, because if you remove the parentheses, then you can check the precedence of the dereference and the dot operator. The precedence of the dot operator is higher than the dereference operator, so the dot operator will be executed first. Then you will have syntax error, because you cannot use a pointer with the dot operator to access some member. So we can do some experiments. For this example, so here I declare an object date1, and I also declare a pointer dptr, and the dptr will point to date1. And then we can use this pointer to access the members of date1. So here I use the dereference operator. And after dereference, we get an object. So then we can use this object to retrieve its member data. And here you cannot remove the parentheses. Because if you remove this parentheses, then the dot operator will be executed first. Here is the precedence table, and we see that the member access the dot operator its member access operator, its precedence is 2. While the dereference operator its precedence is 3. So the data operator has higher precedence than the dereference operator. And therefore, the compiler will execute dptr dot getMonths first. However, dptr is a pointer to an object, not an object, so we cannot use a pointer with the data operator to access member data. So here we need to add the parentheses, or you can choose not to use the reference. You can directly use the arrow operator. So this operator is for pointers to access member data or member functions. This arrow is frequently used in the C programming language, because in the C programming language, when we usually use call by reference, and when you use call by reference in the C programming language, you need to send some pointers, and when you want to use pointer inside some function, then you usually use the arrow operator. So this operator is very common in the C programming language. Next, let's go to the page 32. This page shows the big three for a class. The big three means the copy constructor, the assignment operator, and the destructors. So the 3 functions are called the big three for a class. Here I show some example. Now suppose we use the C++ string to declare an object str1. For this statement will call the default constructor of the string data type. And now suppose we declare another string str2. And we call a constructor, so we add a parenthesis after str2. And now suppose we want to use str1 as the initial value of str2. Then we will call the copy constructor. So copy constructor means we want to copy some object of the same data type as the initial value of str2. So this is the copy constructor. Next, I will introduce how to define a copy constructor. And here I assign some C string to a C++ string. So this line will use the assignment operator. And the variables are defined in some function. When this function is finished, the scope of the two variables terminate. And when the two variables terminates, then the destructors will be called. So when this function is finished, then the destructors of str1 and str2 will be called. The three functions are called Big Three because if you need any one of them, then you need all of them. This means if you need to define the copy constructor, then you usually you also need to define the assignment and the assignment operator and the destructor. For class for any class that use pointers and the new operator, we usually need to define the Big Three. So if you need to allocate memory by yourself, then you usually need to define the Big Three. Let's see this example. This example defines a class partially filled arrays. Let's see the definition of this class. For this class, we have the default constructor because this constructor has no inputs, and we also have the copy constructor. Copy constructor means the input data type is the same as this class. So this is the copy constructor. And we usually use call by reference. So we used we add the ampersand operator because call by reference is more efficient than call by value. So here we add the ampersand operator. And we also add the const modifier because we will not modify the input, the first input, the function input. So here we add the because we only perform copy operation, and we will not modify PFA object. And we also have the third version of the copy of the constructor. This constructor has only one input. We also have the destructor, and destructor is similar to constructor, except that we add the tilde character before the function name. So to define a constructor, to define a destructor, you add the tilde character before the class name. And for this class, we have three members. The first member is a pointer to some double variable, and actually this is, you can regard this as a double array. Later we will allocate memory space and let A points to this memory location. So A will point to some double array, and the remaining two member data is capacity and used. Capacity means how many elements we want to allocate, and the used means how many elements we used for this double array. We also define operator, the assignment operator. So you can regard the assignment operator as a function. The right hand side is input. So the right hand side of the assignment operator is input, and its data type should be the same of this class. So its data type is the same as P of array D. And here again we use call by reference. So we add the ampersand operator, and we also add the const modifier because we didn't modify right side in this implementation. And this operator will return an object. So this operator will return an object the same as PF array D. And we also define another operator, bracket. Bracket is used to access array elements, and we will define this operator because we need to use this operator to access the element in the double array. And its input is the index. We will use this index to access array elements. And this operator returns a double because this array is a double array, so its element is of data type double. So the operator, the return data type of operator bracket is double. And the next, let's see the definition of the constructors. Let's see default constructor first. Default constructor means we do not supply any inputs, and the capacity is set to 50 by default, and the use is set to 0 by default. And the pointer A, we will use the new operator to allocate memory space of 50 elements, and each element is of data type double, and the new will return a pointer pointing to the allocated memory space, and this pointer is assigned to A. Next, we define the copy constructor. Next, we define the second constructor. The second constructor accepts one input, and this input is used to initialize capacity. So capacity will be initialized to size. And again, capacity is the number of elements we want to allocate, and the use is set to 0. Next, let's see the copy constructor. Copy constructor is here. The input of copy constructor is an object. The data type is the set of this class. So the data type is also PF array D. And we will use PFA dot capacity to initialize capacity, and use PFA dot used to initialize used. And then we need to perform copy. Since this is the copy constructor, we need to copy the double array of in PFA to our object. First, we need to allocate memory space. So first, we allocate memory space to pointer A, and then we need to perform element-wise copy. We copy each element in PFA dot A. So we copy each element in PFA dot A to the allocated memory space. So this is the copy constructor, the definition of the copy constructor. We can start to use this class, and you can go to the reference web page. This link is in the first week. You can go to the reference web page, and you can find in this web page you can go to pointer and dynamic arrays, and you can find test class PF array D. So we can start to use this class. So we use PF array D to declare object PFA1. Then you can call add element member function to add some element. Then use show array to print the elements in this array. We see that if you did not add any element and you call show array, then show array will print nothing. So here is show array only prints a new line. This is because we call the default constructor. And in default constructor, so here in default constructor, we only allocate memory space, but used is 0. Let's see the definition of short array. So short array, so the definition is here. Short array will print used, the number of used variables. If used is 0, then the for loop will not be executed. So when used is 0, the for loop will not be executed. So only the new line will be printed. So if we call the default constructor, used is 0. And therefore, if you call short array will print new line. And after we add 2 elements, used will be increased by 2. And when we call short array will print the elements. The definition of add element is here. When we called add element, first the if statement will check whether use is greater than or larger than capacity. If this condition is not satisfied, this means the capacity is not enough. And in this case, we need to do something. So here we choose to exit this program. Or you can choose another solution. For example, if this condition happens, you can choose to allocate memory space and do some other operations. And here we choose to if this if statement is true, we choose to exit this program. And if used is smaller than capacity, then we will assign the input element to this element. This is the element at the index used. So used is the index. So we use this index to access the value in the double array A. And after we perform this assignment, we increase the index used by 1, because we only add 1 element. Time is up, so let's take a break for 10 minutes. Hello, let's continue our class. We already introduced the 8-element function. Next, let's see the destructor. This destructor is in contrast with the constructor. Destructor means when we destroy the variable, then destructor will be called. So this destructor will be automatically called when the object is out of scope. And for this class, we need to manually define the destructor because we allocate memory space. If you do not define destructor manually, the default version will not return the allocated memory space. So if you allocate memory space in a class, then you need to define the destructor. Otherwise, the memory will not be returned. And here we use the delete operator followed by bracket because we allocate the memory space of a double array. So here we need to add the bracket after the delete operator. We already see the copy constructor. So copy constructor means we want to copy some object. We want to use the copy some object as the value of some object as the initial value. So the input parameter is of the same data type of the class for copy constructor. And this parameter is usually is called by reference. So here for this example, the input parameter is of the same data type of this class, and it is called by reference. So we use the ampersand operator. And here we add the constant modifier because we didn't modify PFA inside the implementation. Below are some remarks about copy constructor. Copy constructor will be called when we declare an object based on another object of the same class. So this is the first scenario when copy constructor will be used. This slide mentions the other two scenarios. The first one is when we call a function, and this function returns an object. When a function returns an object by value, then the copy constructor of the return object will be called. Or when we call a function, and this function has an argument. Has an object as an argument, and when we call this function, if this function is called by value, then the copy constructor of this object will be called to return a value. So these are the three scenarios where copy constructor will be used, but this is not guaranteed. the above three scenarios is not guaranteed because this depends on the implementation of the compiler. Some compiler will optimize your code, so sometimes some copy constructor will be skipped in order to make your code more efficient. Next, let's talk about shallow copy and deep copy. We already defined the copy constructor, and the way we define this constructor is called deep copy. Deep copy means we allocate new memory space, and we perform element-wise copy. And in contrast, we also have the shallow copy. Shallow copy means we do not allocate new memory space. We simply perform pointer assignment. We simply assign PFA.A to A. So we simply perform pointer assignment. The next slide shows a figure to compare shallow copy with deep copy. So you can see this figure. For deep copy, we allocated a new memory space. So both PFA2 and PFA1 has its own memory space. But for shallow copy, we do not allocate new memory space. So we only perform pointer assignment, and PFA2 is point to PFA2.A points to the memory location points by PFA1.A. So for shallow copy, PFA1.A and PFA2.A share the same memory space. We can do some experiments about deep copy and shallow copy. So first I declare PFA1, and I add two elements to PFA1. Then I declare PFA2 using the copy constructor. So PFA1 will be copied to PFA2. So PFA2 will have the same elements as PFA1. So the first line is PFA1 and the second line is PFA2. Now suppose we modify the elements of PFA2. PFA2. Now suppose we modify the first element of PFA2. The first element is set to 3, and then we print PFA2. We print PFA1 and PFA2. we see that PFA1 remains the same. So PFA1 uh, PFA1 remains the same, but the first element is modified. The first element of PFA2 is set to 3. This is deep copy because PFA1 and PFA2 has its own memory space. So when you modify the first element, this will not affect the first element of PFA1.A. Next, I will show shallow copy. So to do this, let's modify the definition of copy constructor. So here I will comment out the comment out this implementation. So here I do not allocate memory space. Here I simply perform pointer assignment. So I assign PFA object.A to A. So and this will not allocate memory space. So you can refer to this figure. So PFA2.A points to the memory location of PFA1.A. So for shallow copy, here I perform pointer assignment. And let's run this program again. We see that both you modify PFA2, but PFA1 is also modified because PFA1 show array shows 2.3. So this means the first element of PFA1.A is modified. This is because PFA1 and PFA2 share the same memory space. So if you modify PFA2, PFA1 is also affected. And here we also show, we also see a warning here. This warning is double free. Double free means we call the delete operator twice. Because when PFA1 is out of scope, its destructor will be called. So when destructor is called, then the memory space of PFA1 will be freed. And when PFA2 is out of scope, then the destructor of PFA2 will be called. But PFA1 and PFA2 share the same memory space, so the memory space is already freed. So if you call the destructor of PFA2, this will cause double free because you free the same memory space twice. So from this example, you can see it is challenging to deal with memory issues. So memory issues are sometimes very complex. we have finished the copy constructor. Next, let's see operator overloading. Operator overloading means you can treat operator as a function. For example, when we perform x plus 7, and here plus is an operator, and this operator has two inputs, x and 7. So x and 7 are the inputs of this operator. So you can regard a plus as a function, and this function accepts two inputs. And after we perform x plus 7, this expression will generate a value. So this function has to return a value. This value is the sum of the two inputs. So when you implement a plus, you need to return a value. This value is the sum of the two inputs. Similarly, we can overload built-in operators like the assignment operator. The principle is that you always overload operators with meaningful actions. You don't overload them with some weird actions. So here we overload the bracket. A bracket means we want to access the array element. So its input is index, and we will return the element at the index at the position index. So you see that the return data type is double, because the element in A is a double. And we also perform a check. We check whether index is greater than or equal to used. We need to check this condition, because if this condition is violated, then we have index out of range. So this check is to avoid the problem of index out of range. And when index out of range occurs, exit will be called, and the program will be terminated. The next operator is the assignment operator. This operator is used when we want to assign one object to another object. For example, here, suppose we do not use copy constructor. Suppose we use so here, suppose I declare PFA2. Here I use the default constructor. Then I need to assign PFA1 to PFA2 if I want to perform copy. So this statement will call the assignment operator of this class. So this statement will call the assignment operator to assign PFA1 to PFA2. Actually, you can try to, if you don't perform assignment, you directly you directly assign some value to its element. This will cause index out of range. So we see that if you directly assign 3 to element at the index 0, this will shows some error message. So illegal index in PF array D. This is due to this line. Because we use default constructor, and for default constructor, user is 0. User is 0, and your index is also 0. So this condition is satisfied. So the if statement is executed. And if we perform assignment, then used will be set to the size used PFA2 will be set to 2 because PFA1 has 2 elements. So next, let's see the implementation of the assignment operator. This operator accepts one input. It's the right-hand side of the assignment operator, and its data type is also P of array D. And we use call by reference. So here we use the ampersand operator. First, we will check whether capacity is equal to right side dot capacity. So we want to ensure the capacity of the right hand side is the same as the capacity of the left hand side. And if this condition is not satisfied, then we will reallocate memory space. First, we will delete the left-hand side. We will return the memory space of the left-hand side. Then we will allocate memory space, and the capacity is adjusted to the capacity of right side. So after this if statement, the capacity of right hand side and the left hand side will be equal. And then we need to set some value. We need to set capacity, and we need to set capacity and set the value of used. And then we perform element-wise copy. We copy each element in the right-hand side to each element of the left-hand side. So after this, we need to return a value, because the assignment operator need to return some value, and this value is the object itself. So the return data type is P of array D. So how can we return the object? So how can we return the object of P of array D? And to do this, we need to use a use a keyword. This keyword is this. So we need to use this keyword this. And actually, we can see the next slide. Actually, this is a pointer, points to the calling object. So for example, when we define a member function, we can access member data inside this member function. we already use method 1. You can have another choice. You can use method 2. You can use the list pointer to access member to access member data. But we seldom use method 2 because it seems redundant to write the list pointer. Since we can omit the list and the arrow operator, so we usually use method 1. However, in the implementation of the assignment operator, when you want to return the object, when you want to return this object, you need to use the list operator. We perform dereference. We dereference the list operator, and this means we get the value of this object. So for the assignment operator, we return the value of this object, and this can be achieved by the list pointer. The reason why assignment operator needs to return a value, this is because sometimes we want to perform assignment chains. So after assign C to B, we want to assign some value to A. So if we want to perform assignment chains, the assignment operator must return a value, and we use this value we assign this value to another variable, and therefore assignment operator must return a value with the same data type as its left hand side. And this allows chains to work. The implementation of the assignment operator will be not included in the final exam because this is a bit more advanced. So the implementation of the assignment operator will not be included in the scope of the final exam. And we have finished the slides. And this semester, we already covered some major concepts in C++. We cover in this semester we learn from chapter 1 up to chapter 10, and C++ has more contents like namespaces, string and file input/output, and also some object-oriented programming related features like inheritance or polymorphism. and also some more advanced topics like templates. We also cover some library in the STL, the standard template library. We introduce the vector library in the STL. We also introduce the sort function in the algorithm library. Here I will introduce some interesting videos. Maybe we can learn something from these videos. This is the first video.
I got into programming basically because of a mistake. I got into programming. Yeah, it's hard to give advice.
So this person is the creator of the C++ programming language. He is Biani Strauss-Stroop. So here is the advice from the creator of C++. He says it is hard to give advice, at least as hard as to take advice.
At least as hard as to take advice. Don't over specialize. Don't be too sure that you know the future.
So first, he mentioned don't over specialize. This means you do not try to learn all the aspects of some subject. For example, you don't try to learn all the contents in a textbook. It's impossible. It will take a long time to learn all the features of C++. If you do this, you specialize in C++. However, this will take a lot of time. If you have a lot of time, you should consider to learn maybe another programming language. For example, you can learn Python.
Be flexible, and remember that careers and jobs is a long-term thing. There's too many young people think they can optimize for something, and then they find they've spent a couple of years or more specializing in something that may not have been the right thing. In the process, they burn out because they haven't spent enough time building up friendships and having a life outside computing. I meet a lot of sort of, I don't know what we can call them, junior geeks that just think that the only thing that matters is their subspecialty of computing, programming or AI or graphics or something like that. And well, it isn't. And the rug might be pulled under them for that. And if they do nothing else, well, if you don't communicate your ideas, you could just as well do Sudoku. You have to communicate, and a lot of sort of caricature nerds forget that. They think that if they can just write the best code, they'll change the world. But you have to be able to listen, you have to be able to communicate with your would-be users and learn from them, and you have to be able to communicate your ideas to them. So you can't just do code, you have to do something about culture and how to...
So you can not just only learn programming. You also need to understand our culture and how to express your ideas and communicate with others.
Express ideas, and I mean, I never regretted the time I spent on history and on math. Um, Math sharpens your mind. History gives you some idea of your limitations and what's going on in the world. And so don't be too sure. Take time to have a balanced life, and be ready for the opportunity. I mean, a broad-based education, a broad-based skill set, which is what you build up when you educate. You're basically building a portfolio of skills. Means that you can take advantage of an opportunity when it comes along. You can recognize it sometimes. We have lots of opportunities, but a lot of them we either can't take advantage of or we don't notice. It was my fairly broad education. I'd done standard computer science, I'd done compilers, I'd done multiple languages. I think I knew 24 at the time. And I have done machine architecture, I've done operating systems, and that skill set turned out to be useful.
So the broad education you received in the university might help you in your future career. I have another video. This video is about how NASA writes space-proof code. So NASA is so NASA is an agency of the U.S. government, and it's about civil space program. So like you send a satellite or rocket to the space, and to do this you need to write some program, and you need to ensure your program cannot have any problems. You must to ensure your program is perfect, and to do this, the NASA has some principles how to write programs without bugs, and let's see the principles.
But what if your production environment is in space? A null pointer dereference or a use after free sends your satellite hurtling into the ether with no way to control it. To avoid this, NASA has a set of rules centered around making their code easy to statically analyze. The rules I'm going to talk about are actually derived from a set of 10 rules that NASA has, referred to as the Power of 10. Gerard Hulsman, a developer for NASA at their Jet Propulsion Laboratory for Reliable Software, acknowledges that some of these rules are a little strict, but in scenarios that require extreme safety, he says the trade-off is worth it. NASA restricts their code to simple control flow constructs. This means that they do not use goto statements or set.
We don't introduce goto. Goto is a special operator in C programming language. You can use this goto to jump to any statement, and this statement will cause your control flow. This goto statement will makes you hard to control your control flow because it can jump anywhere.
Jump or long jump. They also do not use recursion. Recursion, or a function.
Recursion means you call yourself. So because you call yourself in the same function, and this will makes your program hard to trace, because you need to trace the function code repeatedly, and this makes your program hard to be controlled. So NASA will avoid using such a mechanism.
That calls into itself creates very hard to follow cyclic code control flow graphs. Recursive code can lead to runaway code, which can crash, especially in embedded systems. NASA gives all of its loops a fixed upper bound. Now, this may sound obvious, but there's actually a little more nuance in this rule. For example, when traversing a linked list, the end case of the linked list may just be hit a forward pointer whose value equals 0. But to prevent an edge case that leads to runaway code, NASA will always put a top limit of the amount of iterations that a linked list traversal.
So here we see that this while loop will check the value of e. If e is 0, then the while loop will terminate. However, when e is not 0, this while loop will run forever. And so here this code adds some additional condition. This additional condition is to ensure if the iteration number is greater than max iter, then this comparison will generate false. And even if in this case, even if e is non-zero, and the overall value is 0, is false, so the while loop will terminate. So this can prevent infinite while loop.
Will take. All loops are bound by a hard upper limit that is represented as an integer, not as a pointer end case. One of the most interesting rules is that NASA recommends that you do not use the heap at all. You exclusively use stack memory.
This means NASA do not suggest to allocate memory by ourselves, because allocate memory by ourselves is sometimes dangerous.
The reason for this is a notable amount of memory bugs do come from the use of the heap and garbage collectors. These systems cannot be proven by a static code analyzer. By limiting your code to only using stack memory and setting an upper bound.
So in the program of NASA, they only use static arrays, because they can estimate the memory size, because this is static array. Its memory size is fixed, so they can estimate the memories required. However, this can waste memory, because we need to use the upper bound of the memory size. But they choose this because they want extreme safety.
On the amount of stack memory you can allocate, you can predict exactly how much memory your program is going to use. By not using the heap at all, you completely eliminate use after freeze and memory leaks. The next rule seems a little pedantic, but it actually makes a lot of sense when you think about the implication. A function should do one thing. Now, the function may require multiple steps to do that thing, but the function should only perform a single action. To ensure this, and to ensure that the code is readable, NASA recommends that functions should be no longer than 60.
So here is the principle for write a function. The function should only have one single perform single task, and should not be too long.
Lines, or about the size of a piece of paper. Writing your code this way ensures that someone else auditing your code can quickly and easily read a function and understand what that function does. It also ensures that your function is small enough and concise enough to be testable as a single unit. If your function is 400 lines and has several layers of nesting, it's often a sign that your code is poorly structured and not well thought through. NASA supports the idea of data hiding, or declaring variables as they're used at the lowest scope possible. Again, all these rules are centered in writing safe code and code that is statically testable. By declaring variables at the lowest scope required, you not only reduce the amount of...
So in this example, he used global variables. You see, G message is declared outside main. So this variable is global variable, and and every function can access this global variable, and therefore it is hard to identify which function crops this global variable. So as I said, do not use global variable. And so the how to protect your data is very important.
Code that can access those variables, but you also reduce the amount of places that can go wrong when debugging why a variable has an erroneous value. This next one seems obvious, but is actually a pretty common issue when I'm reading the code of junior developers. Check all of your return values for non-void functions. All of them. It's very easy to read the man page for a function and figure out what it does, but to ignore the return value section for a function that should always behave properly. A hidden code obfuscator calls out the C preprocessor as a hidden code obfuscator that can destroy code clarity and befuddle many static code analyzers. The power of 10 specifically calls out conditional
This principle is about do not use C++ preprocessor. C preprocessor. C preprocessor is like this, begins from like this. If you use this will make your program hard to be compiled and hard to understand.
Compilation, or having flags that change your code at compile time. For example, if you have 10 different flags that can be changed at compile time, you essentially create 2 to the power of 10 compilation targets that need to be tested, exponentially increasing the testing requirement of your code. This makes the code hard to scale and hard to test. Another interesting rule by NASA is the
restrict pointers use, because pointers are indirect and therefore difficult to understand.
Restriction of pointer use. The power of 10 calls out pointers and says that they should not be able to be dereferenced, all warnings enabled, and compile in pedantic mode. Doing this
when you compile your program, you should turn on all the warnings. So here is the switch for this command, pedantic. This switch can show all the warnings about your program. For example, it can show some variable is not initialized, and this can help you to detect the potential problems.
Ensures that every possible problem the compiler sees with your code will be raised and treated as an error. After this, make sure your code is analyzed using multiple static code analyzers.
And this is the final principle to test your program and test. This is similar to when you send your assignment. After you, before you send your assignment, you should also test your program as much as possible. And our class has already ended, and we can now dismiss.